Welcome to this video on Java Array Reference Data Type. We have seen in previous videos what are arrays, how do we access array elements used individually and using a for loop. We have seen how do we search through arrays using linear search and binary search. And in this particular video, we are going to look at the different methods in which we can sort arrays. So what is sorting? Sorting is arranging your items in a particular order. Okay, so here we have some random items 2, 4, 3, 1. When I arrange them in a particular order, this would be ascending order. I would arrange them as 1, 2, 3, 4. Okay, so suppose this is my array of elements. Okay, by now we know an array is an ordered collection of items of the same data type. So this will be my array of integers, which has 5 elements in it. And this is in random order right now, in no particular order. If we were to arrange these items in a ascending order, how would they be? The smallest, ascending means small to big. So the smallest element, 27, would be first, followed by 30, then 45, 84, and 90. Descending order, what happens in descending? The biggest element or the largest element comes first, okay, and the smallest element comes at the end. So the descending order would be 90, 84, 45, 30, and 27. Fine. Now that we know what sorting is, we are going to look at two particular sorting algorithms in Java, bubble sort and selection sort. Okay, so let us first have a look at bubble sort, how it works, and then we will look at the Java program for bubble sort. How does bubble sort work? Okay, in bubble sort, so we are taking an example of 5 array elements. Imagine our array 8 has these 5 array elements, and we want to sort this particular array in ascending order. Ascending order means small to big. So we are looking at the bubble sort algorithm. In bubble sort algorithm, B, you can remember it that way, that B stands for beside. Okay, so what we do, we compare elements which are next to each other. Okay, so we only compare 45 with 90 and we decide, are they in the correct order? Forget the rest of the array. At this point, we are only checking whether 45 and 90 are in the correct order. What is the correct order we want? Ascending. So 45 should come before 90. Yes, they are in the correct order. So we don't do anything. Our array remains as 45, 90, 30, 87, and 20, 84 and 27. Okay. Next, what do we compare? The next two elements which are next to each other. Okay. So we compared index 0 with index 1. Now we will compare index 1 with index 2. 90 and 30. Are they in the right order with respect to each other? Forget the rest of the elements. With respect to each other, 90 and 30 are not in the correct ascending order. So what we will have to do, 45 will remain as it is. We don't change 45. We will swap 30 and 90. So 30 will come first and 90 will go second. Anytime swapping is involved, we need to make use of a temporary variable, which we will see in the code. Okay. 84 and 27, right now, we are not looking at them. So they remain as it is. Similarly, following on, we would now compare index 2, okay, which is right now 90 with 84. Are they in the correct order? No, 84 should be before 90. So we would swap them and hence 84 will come at index 2 and 90 will go to index 3. Okay, and 27 remains as it is. Continuing on, we need to now compare index 3, this element, with the last element. Again, 90 and 27 are not in the correct order. So what we would do, the first 3 elements remain as it is. 27 would come first and then 90 would come afterwards. Okay, so we have completed, okay, if you look at this, we have completed one pass of the array. We have compared all the elements which are next to each other, okay, and at the end of pass 1, if you see, element 90, which is the largest element, has reached its correct position in the array. And hence the algorithm is known as a bubble sort. The element has bubbled to its position. You can see it moved from index 1 to index 2, then to index 3, and finally to index 4, which is its correct position. And the array gets sorted from behind. B for bubble, B from behind. So this 90 is now in its correct place. Okay. This is one pass of the array. Do we think our array is sorted? No, our array is not sorted. So we need one more pass, which means in coding terms, it will be one more loop, okay, through the entire, more iteration through the entire array. So what will we do? Now this is, after pass 1, our array will look like this. We again start comparing index 0 with index 1, 45 and 30 now. Are they in the correct place? They are not in the correct place. So I will swap them. 30 will come first, 45 next. The rest of the array elements remain as it is. We now compare 45 with 84. They are in the correct place. So the array remains as it is. We don't do anything. Third, we have to compare whatever is at index 2 at this point, which is 84 with 27. Are they in the correct position? No, they're not in the correct position. So I will put 27. I will swap 27 and 84. 90 remains as it is. Now, do I need to compare 84 and 90? I don't need to compare because 90 we know for sure is in the correct place. So when we do the second pass of the array, we only need to compare the first 4 elements with each other. We have to go on reducing the number of comparisons. Okay. At the end of pass 2, what has happened? 84, the second highest element, has reached its correct place by bubbling through the thing. Okay. So this is pass 2. 2 elements have reached their correct place. Continuing on, this is the position now after pass 2. Compare 30 with 45. No change. So the array elements remain as it is. Compare 45 with 27. Yes, they should change. Okay, they are not in the correct order. So 30 remains as it is. 27 comes first, then 45, 84 and 90. Now, do I need to compare 45 with 84? No, these two are already sorted. I know that these two are already in their correct place. So there will never be a swap at this point. So we will stop pass 3 at this point. 45 has reached its correct place. Okay, each element is bubbling to its correct place and the array gets sorted from behind. Okay, still not finished. So now we have pass 4. Our array looks like this. We have to compare elements next to each other. So we compare 30 with 27. Not in the right order. So 27 should come first, 30 next. The rest of the array elements remain as it is. At the end of this pass, which is pass 4, 30 is in its right place. Okay, array gets sorted from behind. The element, first element, obviously it is by itself. It is in its correct place only. So at this stage, we say the array is sorted. Okay. So an array of 5 elements would need 4 passes through to it to get it sorted. Okay. So 4 passes means there is a loop. And in each pass also we are comparing next to each other. So that is another loop. So a bubble sort algorithm will have 2 for loops in it. Okay. Fine. Now that we have looked at the example, let us just look at the definition. In bubble sort, the entire array is scanned comparing 2 adjoining elements or 2 elements which are beside each other, and we are exchanging them if they are not in the right order. Okay, that is the whole algorithm. If the array has n elements, then we need to repeat this process n minus 1 times. In our case, we had 5 elements. So we had to repeat the process 4 times. Okay. After one pass of the array, one element of the array bubbles to the correct place. Which is the correct place? At the bottom or the behind of the array. Okay. That element reaches its correct place after one pass of the array. Okay, this is just for you to remember. B for bubble, B for checking elements which are besides each other, and B for just to know that the array will get sorted from behind. Okay, fine. Okay. Now, let's have a look at the code. And there are 4 different examples that we need to look at. So, let us look at the first example where the array of numbers, we need to sort them in ascending order. Okay, second example will be array of numbers in descending order. And then it will be array of strings in ascending order and array of strings in descending order. Okay, so 4 examples we need to look at. First, we'll focus on array of numbers in ascending order. So we come to BlueJ here. Okay, you can use any editor of your choice. We'll make a new class and this will be bubble ascending. Okay, we are going to make a class called for bubble ascending. Fine. Did this. So to start any Java program, if we have to take input from the user, we need import java.util.scanner. Okay, then we start with the class name. So we say public class. What is our class name? Bubble ascending. Okay, that is our class name. Underscores are allowed in a class name. Inside this, we will write a method, which in our case will be public static. I will say void sort numbers. Hyphen is not allowed. Sort numbers ascend. Okay, this is my method. What do we need to do first? Okay, we need to take input. Any program consists of three parts: input, processing, and output. Okay, so first we need to take input from the user. So we'll say input array elements. Fine. Next, what will we do? Sort array elements in ascending order using bubble sort. Okay, and third thing is output the sorted array. Fine. Any program has three things: input, processing, and output. And these are going to be three. To input anything in Java, we need to make an object of the scanner class. So we say scanner sc is equal to new scanner. And we point it to where our system.input is. Okay. We need an array. So we declare that. I'll declare my array A. For this example, we will keep it as an array of 5 integers. Anytime we need to take input from the user, we need to tell the user what it needs to do. So we will write a message here, enter 5 array elements. Okay. Now, since we need to take more than one number from the user, what do we use? Anytime we want to repeat something, we have to use a loop. Okay. Generally for arrays, we use a for loop. So my for loop would be for int I is my counting thing. First valid index in an array is 0. So I will say I is equal to 0. I should be less than what? A dot length. What will A dot length be in this case? Length will be 5. Okay. And increment by 1 every time. What do? We take A of I is equal to sc dot next int. Okay. Whatever number the user is entering will first go in A of 0. It will then go in A of 1, A of 2, and so on till A of 4. Okay. So this is our enter 5 array elements. Fine. Now what we need to do? We need to sort the array elements in ascending order using bubble sort. Remember, bubble has two B's in the center next to each other. So it has two loops. It has two for loops. Okay, you have to remember that. Now the first for loop is how many passes we need. So we said for 5 elements, we need 4 passes. Okay, so the for loop for the first one will be same like the array thing, same, exactly same. You can just copy this, the input one. It will be exactly same. I start with 0. Okay, and I should be less than A dot length. I plus this. Fine. That is my number of passes. In each pass, I have to compare 2 elements which are next to each other. So I need another loop. Call this the j loop for int I is equal, j is equal to 0. J should be less than, now j should be less than A dot length. Okay. Minus of 1. Because I'm comparing things next to each other. 0 with 1, 1 with 2, 2 with 3, and 3 with 4. Solely, I cannot go up to 5. So I have to do minus 1. And also, after every pass, the last one is sorted. So I'm going to do a minus I. Okay. If you forget this, only the program efficiency changes. Otherwise, your code will still work fine. So your I loop is exactly like how you write all your array loops. Okay. I is equal to 0, I less than A dot length. Your j loop is A dot length minus 1 minus I. Okay. And j plus plus. Remember, it's a j loop, so you have to increment j. Okay. What were we doing in each pass? We were comparing things which are next to each other. Okay. So that is our j. So I would say if A of j, okay, is greater than whatever is present after that. Okay. 2 elements. So if I go back here, okay, what are we saying? If this one, if 30 is greater than 45. Okay, first time j is 0, right? So it will say 0, are you greater than A of 1, which is 45? If only if they are greater, that means they are not in the right order, we have to do a swap. Okay, swap elements. Anytime we have to do a swap, remember this, we need a temporary variable. I cannot, if I put 45 and 30 right away, I will lose the value of 30. So what I have to do, I have to store, I say int temp is equal to A of j. The first value here, which is there, A of j, I will put it in temp. Okay. Then whatever is the right side would become the left side. In A of j, I will put this, the next value, A of j plus 1. Okay, so if you look at this example, in temp, 30 will be stored in temp. Okay, and in place of 30, 45 will go. If we were doing a swap here. So in this case, we're not doing a swap. We should take here, right? We have to do a swap at this point. 90 and 30 have to get swapped. So in this case, we would put it in temp and then move it across. Okay, so temp is equal to A of j, whatever is first here goes in temp. A of j comes here to the left side. What comes here? A of j plus 1. Again, A of j plus 1 comes to the left side. And what will go here? Whatever was in temp will go here. And this completes the if. Okay, and that's it. The inner for loop is done and the outer for loop is also done at this point of time. Okay, that is all we are doing. This inside is one pass through the array. And like that, we need n minus 1 pass. So if the array is 5 elements, we need 4 such passes. Okay, so this is the processing for bubble sort. Finally, what we have to do? We have to output the sorted array. Okay, so output again, what do we first? We tell the user sorted array is. Okay, anytime you have to display the array or input the array, this same for loop is used. Okay, so just to show that it is the same, I'm going to do a copy paste for int I is equal to 0, I less than this. But this time, instead of taking an input, what are we doing? We are displaying it out. So I would put a print so that I get them all on the same line. A of I plus some space. Okay, we'll just put a space like this and then close the for loop. Fine. So that completes our method and that completes our class. Okay. We have a class. We have a method inside it. We first took input of the array elements. We then sorted the array elements using bubble sort. Okay. And then we are going to output the sorted array. Fine. Let us just try and compile this. Class has been compiled. No syntax error. Okay. So now let us try running this program, bubble sort ascending. We do a right click and it shows us this method. Because I made it a static method, it is directly available. Void sort number ascending. So it is asking me to enter 5 array elements. Let me enter them in the order in which they are on the screen. So I would enter 45, 90, 30, 84, and 27. You can see it is giving me the output as the sorted array is 27, 30, 45, 84, 90. Okay, so I hope that is clear how the working is and how the program is. Fine. Even working gets asked in theory. They might just give you an array and they will ask you, how does the array look after 2 pass? Now, let us just write the program if we had to make use of bubble sort descending for numbers. So what we'll do is we'll make a new class. We will call it bubble descending. Fine. Now what I'm going to do just to show you how easy it is. Okay. So what we're going to do is we're going to open bubble ascending, copy the entire code. Okay. And open bubble descending, whatever is there, we delete and we paste this code. So now we just need to change the names of the class. So this will be descending. And this will also be, the method is also descending. You're saying enter 5 array elements. I'm just going to change the comment to say sort array elements in descending order using bubble sort. In this case, what we do is we swap the elements if A of j is less than j plus 1. Okay, because we want to send the smallest element to the end. Rest everything stays as it is. Only your if over here changes to less than. Okay, so let me just compile this code. Class is compiled, no problem. Fine. So we have the code here. If we run this sort number descending, it is asking us to enter 5 array elements. Let's enter the same array elements 45, 90, 30, 84, and 27. And the sorted array in descending order is 90, 84, 40. So we have seen at this point how to sort array of numbers in ascending order and how to sort array of numbers in descending order. We will now look at how to solve array of strings in ascending order. Okay, so we come back. So we are going to make a new class, call it bubble ascending for strings. Okay, this is my third program. We are still going to copy the same bubble ascending thing. I'm going to do this, paste it here. Fine. Your class name always has to match the file name. So this will be bubble ascending underscore strings. And here I will say instead of number, I'll say sort strings in ascending. Note method name, class name you can give, you can choose what you want. Okay, just keep it meaningful. Now, I will have to still input the array elements. I will have to create the scanner object, but this time my array will be of string rather than integer. So I will say string, and in here again it will be new string. Correct? I'm making an array of 5 string elements. Fine. The for part remains the same. Only thing here, instead of, because we're not taking an int, I will say sc dot next. Okay. Up till here, fine. I only change the int array to a string. I change the scanner method to accept words instead of integers. For loop, the for loop, both the loops remain the same. Only the comparison changes. Because why does the comparison change? Because strings are reference data types and they cannot be compared directly like this. So what we have to do in this case is, okay, this greater than sign, you take the greater than sign and you put it here, greater than 0. Okay. And here, instead of the greater than sign, you use the compare to method and put this a of j plus 1 in bracket. To compare strings, okay, we can use the equals method or the compare to method. Now, what does the compare to method give? The compare to method gives us a positive, negative, or an equal to 0 number. If this first element is bigger, okay, or it comes later in the Unicode table than the second element, the answer will be a positive number. Okay, so we are saying only if this is greater than 0, the compare to, then we need to swap, and this time the temp also will be a string variable, right? Because we need to put the word inside. So we changed this int to a string. We changed next int to next. The greater than 0, okay, or the greater than thing, we moved it at the end to make it greater than 0 and did a compare to. Fine. Finally, what we do after the processing, output the array, sorted array, that remains the same. We don't need to change. What are we looking at? Array of strings in ascending order. Okay. So let's compile the class. Class is compiled, no syntax errors. Here is our class. Let's right click, run this method void sort string ascending. Okay. So it is asking us to enter 5 array elements, right? Now this time we have to enter words. So let's say we put Delhi, Chennai, Mumbai, and Kolkata, and Pune. You can see the sorted array is C comes before everything. So Chennai, then Delhi, then Kolkata, then Mumbai, and Pune. Fine. I hope this is clear. So once you know the algorithm for bubble sort ascending, you can just tweak it slightly to make it bubble sort descending. Okay, so we have now seen the program of array of strings in ascending order, and the fourth one is array of strings in descending order. So what we are going to do, we now know in descending, we only have to change the comparison part. So I'm going to open this code, do a Control A, Control C, okay, and make a new class. The new class will be called bubble descending for strings. Perfect. Place it here. Double click and open it. Remove whatever is there and change it. So what are we saying? It will now be called descending. It has to match the file name. Class name has to match. We are saying sort string descending. We need to input all the array elements, string array, using next. That is fine. Only the comparison, if a of j dot compare to this would become less than 0, and that's it. Your array will get sorted in the descending order. Fine. So let us just compile the class. Class is compiled, no issues. Okay, so now let's try and run this method, void sort ascending, and it is asking us to enter 5 array elements, which in this case are strings. So let's try and enter the same ones. We have Pune, Pune, Chennai, Delhi, Mumbai, and Kolkata. Fine. Now the sorted array in descending order is P comes last in the alphabetical order. So Pune, Mumbai, Kolkata, Delhi, and Chennai. Let us now have a look at a second sorting algorithm, which is known as selection sort. So we will have a look with an example, and then we will write the code for the same. Okay, so imagine our array, the same array A, which we use for bubble sort, which has 5 elements. And now we want to sort it in ascending order using the selection sort algorithm or the selection sort approach. In this case, what we do is, we have 5 elements in our array. We have the index from 0 to 4. What we do is we decide, okay, and we choose that what should be the first element or what should be the element at index 0. If you're sorting in the ascending order, the smallest element, okay, the smallest element, or how we find the min, the smallest element should be at index 0, which we can see is 24. Now, how do we instruct the computer to do it? So what we do is we make 2 variables, minimum and the position of this minimum. Okay, initially they will be blank. For the first pass, we will assume that this first element, that is A of 0, 45 is the minimum and the position is 0. Okay. Now, we are not comparing elements beside each other. That was bubble sort. We are going to compare this minimum with the next element. So we're going to compare 45 with 90. If 90 is smaller than 45, we will make that this is the smallest element in the array so far. Right now, it is not the case. 45 is smaller than 90, and hence 45 stays in the variable minimum, and the position of 45, 0 stays that. We then compare 45. So remember this, we are going on comparing min with the array elements. So we'll say if min this something A of 2. Okay. Now we are comparing 45 with 30. Which is smaller? 30 is obviously smaller or lesser than 45. So we will say the current minimum, the minimum should be 30 at position 2. Okay, we go on, moving on, we compare now what is the current minimum? Current minimum is 30. So we compare that with 84. 30 is still minimum, so we don't do any changes. And we then compare 30 with 27. So now 27 is smaller than 30. So min will change to 27 and the position of this particular minimum will change to 4. We have finished one pass of the array, and what we have done is we have found what is the smallest element which should be present at index 0. Okay, and now we will do what is known as a swap, which we saw in bubble sort also, but here I am just explaining it. So now I have to swap index 0, whatever is present at index 0, with whatever is present at index 4, which is 27. So what we do, whenever we have to swap 2 elements, we have to make a new temporary variable. So I make a new temporary variable. And I first store 45 in this temporary variable. Okay. Then what we do is we move 27 to A of 0 and we move this 45 back to A of 4. This is how anytime we have to do swapping, this is how it happens. Do note, whenever we move things, the original copy is still maintained. Okay. So in this, I'll explain it in the next thing. Okay, so do note, it is not cut and pasted in a new thing. It is copied and pasted to the new location. Fine. So this is at the end of pass 1. Okay, this will be pass 1. 27, the element, the smallest element has reached its correct position in the array, which is at the start of the array. So in a selection sort, the array gets sorted from the start. S for selection, S for start. Okay, this is pass 1. Now what we are doing? Now we have to find the correct element for index 1, the next one. Okay, so our focus is on index 1 at this point of time. Again, min and pause. What we will say, we'll assume that 90 is the lowest element at position 1. Comparison is with what? With 90 always. Okay, so we are comparing 90 with 30. Oh, 30 is smaller than 90. So we say min should be 30, position 2. We then compare this min with 84. 30 is still smaller, so no need to do anything. Compare 30 with 45. 30 is still smaller. So at the end of the second pass of the array, we find that the smallest element after 27, okay, 27 is sorted, so we don't look at that. After 27, the smallest element or the next element should be 30. So now what do we have to do? We have found the smallest element. We know which position we want to put it at. So what we have to do is we have to do a swap. So when we do a swap, what I was telling just few minutes ago was I will move or I will copy A of 1, that is 90, to temp. Okay, do note 90 still remains here, but we are not using it right now. We copy A of 2 because the position is 2, 30 to this position. And whatever was in temp, we move it back to A of 2. Now what has happened? 30 has come in its correct place. So after the second pass, 27 and 30, two elements are in their correct place. Fine. So this will go on. We now have to focus on this particular index. We will say, assume that that is the minimum. Okay. Compare the minimum with the rest of the elements. 84 is less than 90. So we change that. Next one, 45 is less than 84. So we change it. Now what do? We have to swap. Which one? Okay. We have to swap 45 with 90. Okay. Swapping is the same thing. Move that variable to temp. Okay. Move the last one, A of 4 to A of 2. And move from temp to A of 4. And now 45 has reached its correct place. So the array is getting sorted from the start. Okay. This is the third pass. Fourth pass, we assume we have to find the correct element for position 3, which is 84. We assume 84 is the minimum at position 3. We compare that minimum with 90. Nothing. Fine. 84 is still in its correct place. So we don't need to do anything, but we still need to do the pass. Okay. And so 84 has reached its correct place at the end of pass 4. This is, in short, selection sort, where we are selecting the correct element and putting it in its right place. Okay. And the array gets sorted from the start. Do note, in theory question, they can ask you what will the array look like after one pass of selection sort. Fine. I'll try and include some examples in another video or at the end. Okay. Fine. This is selection sort. So what are we doing? In selection sort, the entire array is scanned to select the smallest element and it is moved to its correct position. Okay. By doing a exchange. The process is repeated to find the next smallest value. So we found 27 first, put it in its correct place. We found 30, then put it in its correct place. We go on doing this till the entire array is sorted. After one pass, one element of the array comes to its correct place. Okay, now let's code. Okay, and we'll be looking at the same 4 examples: array of numbers in ascending order, array of numbers in descending order, array of strings in ascending order, and array of strings in descending order. Okay, so 4 programs. Now for selection sort, we'll come here, we make a new class and we call it selection ascending. Right. We know whatever is there. If you want to take input elements from the user, we need the scanner class. So we say import java.util.scanner. Java.util is a package in which scanner is present and we want it available to us. Java.lang is the default package. Okay, so we want this available to us, hence we do an import. We then start the class, public class. The name of the class has to be the same as what we specified here, selection_ascending. We then have a method. I'm making it a static method. Static methods are class method. So then I don't have to create an object and then call. I can directly call the method. So I say public static void because it's not returning anything. And I'm saying sort number ascending. Not taking any input parameter. So curly, open bracket, close bracket, add and any program. What do? Input. Then we do the processing. And then we do the output. Fine. So input is we need to take array elements from the users, for which first we have to make a scanner class object. Okay. We want to make an array of integers. Fine. Then we let the user know that please enter the elements. Okay. Because we need to take 5 elements. What do we need? We need a loop. The loop remains the same for most array programs. Okay. All the array programs, your input loop remains the same. for int I is equal to first element is 0, I should be less than the array dot length. Okay, I plus plus. This remains the same. Now, what are we doing? We are just taking an input. So we say a of I is equal to sc dot next int because we're taking integer. And because there's only one statement in this loop, I have not put curly braces, but if you want, you can put that. Okay, so my input is clear. I have taken an array of numbers. Processing. Now we are processing or which is sorting in ascending order using selection sort. Okay, so again, there are going to be two loops here. Let us start by writing the code for processing. So the first one remains the same. The I loop, I is equal to 0. I should be less than a dot length I plus plus. Okay, for the sake of simplicity, we'll keep the outside loop as the same thing. Okay. Now, what do we want to do? As we said, for each loop, every time we come in the loop, we decide that what will be the minimum. Okay, so we say int, we'll do because we'll need this variable again and again. What we'll do is we'll declare these outside. So we'll say int min and pos. Okay, the position of that minimum and the min. So we'll say currently I want to decide what should be in location 0. So a of I, then location 1. So a of this will become 1, 2, so on. So I'll say minimum is equal to what is in a of I and position is equal to I. Fine. We are taking the value which is 45. Okay, so here in this case, if we see, what did we take the minimum as? We took the minimum as 45. Okay, which is a of 0 right now. And we took the position as I. What is I? 0. Okay, so this is how it will work. Fine. So every pass, we first decide the minimum is that particular element and the position is that particular index. Okay. Now we need to keep comparing this minimum with all the subsequent array elements. Our inside for loop will be for int j is equal to, we want to compare everything which is after that. Okay, so we say I plus 1. Okay, j should be less than a dot length. Okay, we need to compare with everything and we say j plus plus. Now for this for loop, again, we have to do a comparison. Remember in bubble also, we had the same comparison thing. Okay, but here we are not doing a swap. We are just comparing and then we are deciding what is the smallest element. So we say if, okay, if your current a of j, if it is less than the minimum value which you have decided so far, then we change minimum is equal to a of j and position is equal to j. Fine. This is what we will go on doing inside this loop. Okay, this is what we are doing inside this loop. So what are we saying? If a of 1, in this case 90, if it is less than 45, then we will change it. So we're not going to do that. Right here, this will not happen. Then we will check if a of 2, which is 30, if it is less than 45. Yes, it is going to be less. So we will say minimum should be a of 2, which is 30. Position should be 2. Okay, so remember in bubble sort, everything is inside the nested for loop. In selection sort, we have these two lines before the second for loop, before the nested for loop, and the swap is also outside of the for loop. Okay, so now we have to do a swap. How do we do a swap? Anytime we have to do a swap, what do we have to make? We have to make a temporary variable. Okay, we are going to swap which two elements now? Okay, we are going to swap this a of 0, which is in our case a of I. So I'm going to put this a of I here. What will come in a of I? Whatever was present at that particular position. Okay, which is a of position. Because I want to, in this case, after I finish this thing, finally, what am I swapping? I am swapping 45, okay, which is a of I. I'm putting that into temp. What am I putting in a of 0? Whatever is present as position 4, a of pos. Okay, so I'll put this 27 here. What should come in a of pos? whatever was in temp now. Okay, you can see whatever is in temp will go in A of 4. Okay, so this is the closing the outside for loop. Fine. So we have an outside for loop for multiple passes of the array. For each pass, we go on comparing the minimum with the elements of the array and deciding what is the minimum value at that point, and we will use that for swap. Okay. Once this is done, finally the output, same thing for output. We have the same for loop. Okay, the array for loop. This one, by now we know this. We don't have to think twice about this one. Just backspace it a bit. Okay, so this is the for loop. And now what are we doing? Are we taking input or output? It is output. So it is system.out.print. Okay, and I'll print A of I with a space. Okay, and that completes the method and that completes the class. Fine. So this is the code for selection sort. Yes, the code for selection sort is slightly more complex than bubble sort. Okay, whereas in bubble sort, we just write 2 for loops, compare and swap. Okay, fine. We compile, class has compiled, no syntax errors. Okay, so now let's run this program. So I run the method void sort number ascending. It's asking us to enter 5 array elements. Let's enter these array elements 45, 90, 30, 84, and 27. And the sorted array is 27, 30, 45, 84, and 90. Okay, we have to write the code for selection ascending. So we make a new class, selection descending for numbers. Okay, what did we say? The code will remain almost the same. So I will take this, copy it. Okay, go to selection descending. So you need to learn or go through one algorithm correctly, one of these methods, and then the rest you can adapt to the situation. So I'm saying descending here, and this is sort number descending. Okay, now what will we choose? The array elements will get sorted from the beginning only, always from the beginning. So in this case, it will be the max that we will be choosing. Okay, rather than the min, we will first find what is the largest element, which should come at index 0. Okay, so here it will be if A of j is greater than max. Okay, if it is, then max will change to A of j. Okay, and your swap will remain the same. Nothing changes in the swap, and you get the sorted array after the. Okay, so let's compile the class. Class is compiled. Let's try running it. The descending one. Okay, I'll just erase the previous output. And now I'll enter these elements 45, 90, 30, 84, and 27. And the array sorted in descending order is 90, 84, 45, 30, and 20. Fine, I hope that is clear. The algorithm is a little more complex than bubble sort, but once you practice, you will get the hang of it. Okay, keep this image in mind. What are we comparing? Okay, and then what are we swapping? Okay, if I close this output, now what is the third one we have to do? We have to make a new class, which will be selection ascending for strings. So let us open this code, Control A and delete this, and we will paste what we have so far, and we'll see how we can adapt this. Selection ascending for strings, and we are saying sort strings ascending now. Okay, not this. So now our array is of string. Basic things keep in mind so that you don't lose marks for these steps. You're now making an array of strings. So it should be string, and here also the new one always follows whatever was your class name. Same thing comes over here. Scanner, new scanner. String, new string. Int, new int. Okay, so don't make mistakes over this. So we are making a string of 5 elements. We're saying enter the 5 array elements, and we are taking strings or words. So we'll do sc.next. Okay. Again, we decide the minimum, we decide the position. Now, what did we say? Strings cannot be compared directly like this. Okay. Another thing we'll have to do, the minimum thing will be now a string, whereas the position will be an integer. Okay, the word will change to a string, but the position index 0, 1, 2, 3, 4 remains an integer. Okay, so how do we compare things? We have to use the dot compare to method. We are going to do a compare to min. Fine. Now, if a of j is returning something which is less than 0 compared to the minimum, that means a of j is smaller than that. Okay, so instead of a of j less than min, we write a of j compared to min less than 0. Fine. We decide this during the swap. The temp variable will also be of type string now. Instead of being of type int, it will be of type string. Output remains the same. We just do a loop and we print all the array elements. Okay, so let's compile this class. Compilation done, no syntax errors. Okay, now let's just run this method, sort strings ascending. The output window opens up, the run window. So it's asking us to enter 5 array elements, and this time we have to enter strings. So let's go with the one which we were doing previously: Delhi, Chennai, Pune, Mumbai, and Kolkata. Okay, and in ascending order, the strings are Chennai, Delhi, Kolkata, Mumbai, and then Pune in alphabetical order, ascending alphabetical order. Fine. So this is this. We know very well the fourth program. I'll just quickly do that. So what we're going to do is make a new class here, which is selection. Okay, let's see what the name, what selection, descending strings. Fine. We say, okay, I'm going to create a class and we will copy whatever is in selection ascending, Control A, Control C. Fine. And we have to do, we close these ones, open this. I'm pasting that program here, selection, descending, okay, and sort strings, descending. Array of strings, take the input. Here, what we will say, the maximum or the highest string is what? It will be a string. Same thing here, we will just call it max, though the program will work, but to give meaningful names to the variables, okay? And then here we will say, we'll compare it with max, okay? And in descending order means we have to say, if it is greater than 0, then change it. Okay, so we will change this to max. Fine. Swap part remains the same. The swap part, if you learn it this way, okay, you don't have to change anything for all these 4 programs, okay? Array of strings in ascending, descending, array of strings in ascending, array of strings in descending, array of numbers, and array of strings. Your input remains similar. Okay, the code, only this, the if part over here changes, nothing else changes. Fine, and in the output, we will use a loop again to output all the array elements. Fine, so let's compile. Class compiles, fine. Come back here, right click, choose the method that you want to run, void sort string descending. Okay, I'll do a Control K so that the previous output is gone. Enter those 5 elements again very quickly. Please ignore if there are any spelling mistakes, and now it is sorted in descending order. Pune, Mumbai, Kolkata, Delhi, Chennai. Fine, I hope that's okay. And the 4 programs for bubble sort and 4 programs for selection sort discussed in this video are available at a link mentioned in the description. You can click on that link and copy the code from there. Okay, that's it for now. Happy learning.